One of the questions I get most often is, Mr. Lyle, what should I round this answer to? It's a more difficult question to answer than a student might figure it to be. And the reason is when we make measurements in a science like chemistry, we have to worry about the quality of our measurements. And the way that we do that is by looking at a set of rules known as the significant figure rules that help us determine which digits are actually meaningful in a measurement and which ones are not. Significant figures really could be defined that way. It's the meaningful digits in a measurement. And when you have a measurement that has many significant digits, the quality of that measurement is deemed to be better than one that has fewer significant digits. We have rules for all sorts of circumstances, whether we're reading instruments, reading the recorded measurements of another scientist, or when we're doing calculations. We're going to break this up into a set of 3 videos where we look at each. This first one, we're going to look at how you determine significant figures from reading instrumentation. This is really at the heart of all of the rules that we talk about when we talk about significant figures. And we've already touched on this a little bit, but we're going to spend time today looking at a few different instruments to talk about how you make those readings. But there is one fundamental rule. You always read the number of digits that you're certain of, and then you make one guess. And that guess is still considered to be a significant figure or a significant digit. These rules, this rule, I should say, is the basis for everything else we do when it comes to determining significant figures. So let's look at an item that we've already talked about in class. How about a ruler? I have the same object, but 3 different rulers. And I want to make a measurement of the length of that object. And I'm going to assume that the object starts at 0 centimeters for all 3 rulers. In the first ruler, I have a pretty crude instrument. It has 2 marks on it, 0 centimeters and 10 centimeters. I am immediately forced to make a guess on the length. I know that it is between 0 and 10, but that's really all I know. I have to estimate the length from there. Since it looks like it doesn't take up half the space of the ruler, I'm pretty confident that it's less than 5 centimeters. To me, I think a good guess would be about 3 centimeters. But when I say that, I did make a guess. This first digit in the ones place is my guess. It's the only number that I am able to estimate at all. So we would say that this measurement has only one significant figure, which is not very good in most cases. When I go down to the second ruler, I have a marking at each centimeter. And so I'm able to actually know for certain part of the measurement. I don't have to guess immediately. So for instance, I know now, looking at the marks on this ruler, that object is between 3 and 4. And so I know the first digit in this measurement is going to be 3, and I'm certain of that. It has to be. But if I want to know how much between 3 and 4 it is, I have to make an estimate, okay? So this time I look at the object again. It seems to be just past the 3 centimeter mark. I might say 3.2 centimeters. That 2 right there is a guess. It's an estimate. And you might come up with something slightly different if you made the measurement. And so you might say something like 3.1 centimeters. A scientist would say both of those measurements are equally valuable and equally significant. They both contain a total of two significant figures. So even when I have an estimated digit and a certain digit, both are considered to be significant digits. This is a higher quality instrument, so I get a higher quality measurement and I have more significant figures. The third ruler is even better. There's not just a mark between each centimeter. There's actually a mark for every millimeter on this ruler. I still believe that this is between 3.2 and 3.3 or 3 and 4 centimeters. But now I can actually estimate a little bit better. I might even have to get in there with a magnifying glass to really see that edge. But right now, I'm pretty confident that it's between 3.2 and 3.3 centimeters. And so I'm going to have to make one more guess. This time, I'm going to go out to the hundredths place, and I'm going to guess that it's just past 3.2. I'm going to say 3.21 centimeters. Okay. So I'm guessing in that hundredths place. This measurement would have three significant digits or three significant figures. It's a higher quality tool, so I get a higher quality measurement. Let's look at a few other instruments as well. We know that we measure volume with graduated cylinders. One thing we may not have talked about is that when you measure volume using a graduated cylinder, we look to the bottom of what's called the meniscus. Usually, anytime water or any other liquid is involved, you're going to see that the water level actually dips down and the meniscus is created, and we're reading that instrument off of the bottom of that meniscus. So in this first graduated cylinder, I can see a mark for every 1 milliliter. It appears to be between 63 and 64 milliliters. So I'm going to write down the digits I'm certain of. It's 63 something. Looks like it's about halfway in between 63 and 64. So I'm going to make a guess and say it's 63.5 milliliters. Still a guess, but still significant. That's three significant digits or three significant figures. When I look at the graduated cylinder on the right, I have to immediately recognize that this is a much better instrument. Instead of going from 20 to 30, well, this is actually not a graduated cylinder at all. Look at the scale. I've got to be very, very careful. The scale is actually going from top to bottom. This is more likely to be an instrument known as a burette than it is a graduated cylinder. Still, our goal today is to read instrumentation. And so let's give it a shot. We're still going to read from the bottom of the meniscus. This time we're going down from 20, not to 30, but from 20 to 21. And so as I look at this, this seems to be between 20.3 and 20.4. I'm going to write the digits I'm certain of, 20.3. And I'm going to guess that last digit. It seems to be closer to 20.4. So I'm going to say 20.38 milliliters. I can guess to the hundredths place. This is a higher quality instrument than the first graduated cylinder because it has a mark every 10th of a milliliter as opposed to every 1 milliliter. Okay, let's talk thermometers. Same thing. The top thermometer has a mark each degree Celsius. The temperature seems to be between 16 and 17. So I'm going to look at it. I'm going to make a guess after 16, 16.4 degrees Celsius. You might say 16.3 degrees Celsius. and that would be a valid measurement as well. The bottom thermometer is better. There is a mark for every tenth of a degree. I know that this temperature is between 16.4 and 16.5. So I'm already confident in saying 16.4, but now I have to make a guess. It looks like it's about halfway through. So it would be 16.45 degrees Celsius. So this is a 3 significant digit measurement, and this has 4 significant digits. It's a higher quality instrument. Finally, let's talk about one exception to the rule, sort of. When we're measuring mass, we use something called an electronic balance. Electronic balance is digitally going to display all of the digits of the measurement. The last digit you will often see fluctuate quite a bit. That's really the attempt of the balance itself to make a guess on that last digit. In other words, we don't need an additional guess when it comes to electronic balances. It's doing the guesswork for us. So when I measure mass and it comes out to 1.20 grams, that's exactly what I write down. For a digital instrument, I write down what I see. This 0 is the guess being made by the instrument, and this is still considered to be 3 significant digits. Remember, everything that follows here in the next videos comes from our ability to read instruments and how and when we make guesses. Okay, we'll see you next time.